Alright then, hello guys. Today we're doing another PicoCTF challenge, and the challenge we're going to be doing today is going to be called X60 what, which is a overflow X64 code. Additional details will be available after launching your instance. So we're going to launch our instance, and I already downloaded both of these files in my downloads folder. So we go to CD downloads, and then I list it. I see two things, and I'll just remove solve.py and just redo this. So it says most problems before are 32-bit x86. Now we'll consider a 64-bit x86, which is a little bit different. Overflow the buffer and change the return address to the flag function in this program. So it's basically telling us what to do, which is to overflow the buffer and put the flag function. It says right here we get two different ones. We get, now that we're 64-bit, we have to use 64 bytes, and maybe and then we have the other instruction, which is jump into the second instruction in the flag function. We're getting mysterious segmentation fault. So how do we solve this? So we check cap vuln.c. We see that we have vuln right here, and vuln, it says that we gives us a set of buffer size, and then we get as many gets as we can, and we get buff size is 64. So how do we figure out, how do we overflow the buffer? Just basically wait until we get segmentation fault. So we just run this and just keep running A's until we get some kind of segmentation fault. So that didn't work, so we just try more A's. Segmentation fault right there. We'll just go in the middle. Segmentation fault right there, so just go a little bit less than that. Segmentation fault a little bit less than that. And I'm eyeballing it, so it might not be that perfect. Segmentation fault. So that worked. So what if we do that? So we just copy this, and then we just go 1, segmentation fault, and then copy this, and go 1. So now let's see if we go like this and just cut off 1. And yeah, so it looks like this is a segmentation fault. And just to check, we could probably run a debugger gdb vuln, and then break star main, run, continue, and then I just put this right there, and nothing came out yet. So that's pretty weird. So just cancel this, run, continue, and then we just do one more. Alright, then now we got something. So we got segfault, and we got segfault 413D, and what is this? SI base pointer. So it was pointing at base pointer, and look at these. These are our two A values, which I guess overrode it right there, and it jumped to this value right here, which is 4013D. 441 base pointer, a stack pointer, RIP. So it fell onto this. So if we add, technically, let's see if we add more A's. Continue. Let me just add more A's instead. So let's see. Well, let's just wait for this. So this is a severe segfault right here. Segfault at this value right here. 441 base pointer IP BX stack pointer right here. It looks like I didn't even touch it. So do we need to put more A's? Let's check how many A's does this have right here. We can probably use AI. We could probably use Python too. So yeah, let's see. We could probably use Python. Python 3. Length of this 66. So we took out, so this was 66, but if we go right here, segfault right there at 66. Well, how much is this? Length of $64. So 64 was the one that caused the segfault right here. So technically, if we do R continue, and we give it like 1, 2, 3, 4, 5. Right here, base pointer. Now we got like our base pointer is basically 1, 2, 3, 4, 5. Yeah, 5 A's. Because 41 is basically 5 A's. 1, 2, 3, 4, 5. And base pointer basically means the next instruction is basically gonna run it. That's basically what's gonna run the next instruction. So what we want to be able to do is now being able to change the base pointer, because if you look up what BP does, base pointer, what does RDP do in the stack? Holds the address of the current stack frame, that is the address of the rightmost highest points pointer. And what does the, see, like, holds the address of the base of the current stack frame. So now if we just change the base pointer to what we want it to, which is the address of win, so disass, what does it want us to disass right here? The flag function, disass flag. Let's see, it's asking us to do it on basically after the first push, which is this right here. So basically, if we do something like what, R, so we can do from pwn import all. This is gonna use pwn tools, and then we're gonna use P64, and then just since it's a 64 x64, we just put this ox just like that, P64, and we just copy this and then put this at the end of it. It might not work, it may work. We'll see right now. R continue, then we got 64 right here, and now we're gonna change the stack pointer right here. So we're just gonna copy this bad boy, insert it right here. Yeah, so 6F401D1. So we still got a segfault, but it looks like it worked. It might be because just different values, but if we write Python code, I'm pretty sure we could get this to work. Because right now I'm just like hard coding the values. So we could get this to work just by simply running a script. So nano solve.py. So we're gonna do the same thing from pwn import all, and then we're gonna do elf equals elf, and then just the name of the file, which is ./vol, and then what we're gonna do is lib Yeah, that should work. And then, just to be sure, so that libc matches, we'll do libc equals elf dot libc. And now what we're gonna do right now is do p equals process elf dot path. And then what we're gonna do next is do payload is gonna equal to a bunch of a's, but it's gonna be in bytes times 64, which is what we're going for. And then we're gonna add payload plus equals p64, and then that hex value that we got right here. I'm just gonna add it at the end. And then we're gonna do p dot receive until, I'm gonna do receive all. P receive all. And then we're gonna do p dot send, and then we're gonna do payload. And then we're gonna do p dot interactive and see what happens. So now if we run this, Python 3 solve.py, vol, I think we just do this, elf. Oh, it's capital. Let's see. Receiving all data. I think maybe I went probably overdone it with the receive all. So if you just exit out right here, go to downloads, vol, and then I'll probably receive until this right here. Yeah. And receive until got end of file while interacting. So let's see what's happening here. Is assuming ASCII, no guarantees. Switching to interactive mode. Nano solve.py. Nano solve.py. P equals process elf path payload. Stack it up with a bunch of things. Payload plus equals 64. Oh, let's print payload just to be sure we're sending the right thing. Payload. Is it the same thing as that? Python 3, and then we're just gonna do length of this 64, so yeah, it didn't match it. Flag.txt, got it, yeah. Let's see. 4104 410.123b. 410. Solve 410.40.123b. What if it's not that? So we could probably change this up and go on GDB again just to be sure. Oh, GDB. GDB volt. Break star main, and then run, continue, and then we just do this, and let's just add a bit more A's onto this time. So we'll add 1, 2, 3, 4, 5, 6, 7, 8. And then we'll see stack pointer still didn't get affected. We'll see this. Python 3. Python 3. No, length. How many A's is that? $72. What if we have a little bit more? Let's add one more. Or continue. 1, 2, 3. Oh, see right here. This is what I was trying to get. I was trying to be able to modify it. The RB. No, what was I trying to modify? Yeah. So see, look, you see how it ends because the segmentation fault ended right here. 1, 2, 3 values, and I added 3 A's at the end. So that means basically it's not actually 64, but it was 72. So I needed to add 8 more at the end of it. So if I just copy this and just change on this one right here, because like right now I have full control of whatever it's pointing to, because it was trying to point to this memory address, the 441, but it wasn't able to because it wasn't able to find it. Now that it's able to point to it, I can now simply go inside the code and just change it up. So nano solve.py and just change that to 72. So now my code should work. Hello, and that's basically cat flag.txt. Yeah, it's basically the name of my flag. So now all I need to do is just start up the instance right here, restart the instance, and just change up my code nano solve.py, where this is that, then p equals remote, and then the name of the I guess the server I'm trying to connect to, and then it's 63981 Python 3 solve.py. And now if we type ls, we get the flag PicoCTF, all this right here. So I can just copy this, paste it right here, and submit it, and we solve this challenge. Pretty easy. Nah, I kind of fumbled it at the end where I wasn't familiar with, I guess, not having control of it, because I thought I knew what I was doing, but I guess I didn't really. But yeah, that's the whole thing. You want to be able to control where it's pointing to, because it right here says it got a segmentation fault because it wasn't able to point at the specific value. Right here, we got it. But yeah, that's about it for this challenge. Hope you guys learned something new today. I know I did. And yeah, I'll see you guys in the next one. Peace.